Hello and welcome to my channel. I'm Akram and you're watching Knowledge 360. In the previous video, we discussed about grouping sets, rollup, and cube in PostgreSQL database. And in this video, we'll discuss about window function processing in PostgreSQL. So in this video, we'll explore how window functions work and how they are evaluated, and also we'll see how we can use them to perform powerful row-aware analytics. So window functions, unlike the traditional aggregate functions that collapses the rows, window functions allow you to compute values across related rows while retaining the detail in each row. So let's create a table called sales to set up the example, and we insert some data into the table. So the data are inserted. Now let's see the basic window function. So in the basic window function, what we'll do, we'll find the total sales per employee without collapsing the rows. While we write the window functions, this is how we write one aggregate function, or it can be other functions also. We'll see in a while. So next we apply over and then parenthesis open and close. So partition by clause, order by clause. So those are optional in the window functions. So we can write them or we can omit them. So in this case, we have done the sum of sale amount and over partition by employee name, and we are giving alias as total sales per employee. So let's execute this query and see the result. So here we have got the result, and we can see that all the records are written, and along with that we have also got the sum amount for each employee. So for example, for the employee Akram, we can see that Akram did 1100 of sales and then 1200, and the total amount of sales is 2300, and this 2300 is returned for each row, and same applies for all the employees. So this is how window functions work. Now let's see how we can use the order by in window function. So in this example, we'll calculate the running total of sales per employee. So this is a cumulative sum. So in this case, we have done the same thing as earlier, but we have added the order by sale date. So since we have added the order by sale date, all the record will be order by sale date, and accordingly the summation will be done. So let's see and execute the query and see the result. So this is the output. So for example, for employee Akram, we can see that on this date Akram has done sale of this amount, and this is the total running total, and the next sale was done on this date and it was the sale amount was of this amount, and then the running total become this one. So this is how we calculate the running total using the order by clause in a window function. So this applies to all the employees, and we can see the results here. Now let's see ranking window functions. So in this example, we want to show the rank of sales within each department. So for that, we have applied the rank function. So this is another window function, and over and then partition by department, because we want to see department wise data, and orders by sale amount descending. So let's see the record. So in this case, we can see that there are two departments, one is clothing and one is electronics. So within clothing department, if we see who does the maximum amount of sale, so it's Jyoti, then Devanshi, then Jyoti again, then Devanshi. So this is how we rank the data, and we can see the rank one is for Jyoti for 950 rupees of sale, and then 900, 800, 700. So the same is applied to this department electronics as well. So in this department, Prem did the highest sale, so got the rank of 1, and then Akram 1200, and so on. So this is how we can use the rank function to show the ranking of the sale amount. Now let's see how we can write multiple window functions with the same window. So in this example, we'll see using of a row number and average in the same window specification. Let's see how we did that. First, we took the row number. This is a window function, and we performed the partition by employee name and order by sale date. The same thing we did for another one, for the average sale amount as well. So let's execute the query and see the result. So this is the output that we have got. So we can see here that rank is given and also average is calculated. So rank is given on the basis of sale date and in the ascending order, as we had mentioned in the window function. So each employee got rank 1 and 2. 1 means the first rank 1 means the first sale, rank 2 means the second sale, and so on. So and also we have got the average sale. So in this case, if you see, the first sale was done, so the average was this much, and then the sale was done of 1100, so the average amount is changed. And similarly for other employees also, you can see that on the first sale the average was this much. As the sale amount changes, the average changes. Now let's see how we can write the multiple window functions with different definitions. In this example, we are going to add a second window function with different partition or order. So in this example, we are taking the sum of sale amount, partition by employee name, only this much. And in the second example, we are doing the same, but partition by department, and then order by sale amount descending. So let's execute the query and see the result. So this is the result that we have got. So up to here, this is the normal record that we have written, and this one is the sale amount done by each employee. So we can see for Akram this is the amount, and for other employees also we can see the amount. And the next column is the sum by department. So we can see that department wise sale how much it is done, and also we have one order by criteria. So for Akram this is electronics department, and department wise if we do the sale amount descending, so this is the highest amount of sale that was done. So this is how we have written multiple window functions with different definitions in a single query. Now let's see another example. So here we'll see the ordering example. So PostgreSQL might return results sorted based on the window functions ordering that we write within this parenthesis or in the over clause. But to guarantee output order, we should use an explicit order by. So in this example, we are doing a sum of sale amount, partition by employee, and order by sale date. So this is the same example of a running total where we did the cumulative sum, and then we are performing explicitly order by as employee name and then sale date. So let's execute the query. So here we can see that the result is sorted by employee name first and then on the basis of sale date. So this is how we can explicitly implement the order by in the window functions query as well. Now let's see an example of rows between for frame control. So this is how moving average is calculated using the rows between. So in this case we are taking the average sale amount and over, then the partition by employee order by sale date, but rows between one and the preceding and current rows. So this is how we can calculate the moving average. So let's execute the query and see the output. So here we can see the moving average, or we can say the running average of each employee. For Akram, we can see that the sale amount of this much was done first. So the moving average was this, and then on the next sale amount, this was the sale amount. So moving average is changed to 1150. So this is how moving average is calculated using the rows between. Now let's see an example of filter inside a window function. So in this example, what we will do, we'll calculate the total sales done by each employee, and also we'll apply a filter where we can calculate where sale amount is greater than 1000 so that the count will be as big sales. So let's execute the query and see the result. So here we can see that for example for Akram did two sales, so the total sales is 2. And what was the big sale? So all the sales are big sale because both the amount exceeds 1000. So for next employee, for example Devanshi, she did 700 and 900, so total sales was done 2, but there is no big sale because these are not satisfying the criteria. Another example, let's see for Prem. Prem did 900 and 1500, so total sales was 2, but only big sale is there. Big sale is the big sale because it exceeds the 1000 rupees amount. This is how we can apply the filter in window function. Now let's see how we can write group by and window function together. So in this example, we are taking the average sale amount partition by department. So that is the department average. Next we'll do sale amount minus average sale of department wise. So let's execute the query and see the result. So here we can see, for example, the clothing department. So we can see the department average is 837.5, but for each cell what was the difference? So the first sale was done of 950, so but the department average is this much. So what is the difference? So the difference is 112.5. So for the next example we can see that the sale amount was of 700, but the department average is 837, so the difference is in negative 137. So this is how we can implement the group by and also the different average. In the next example, we will see the entile function for bucketing. So in this case, we are applying the entile 2, and the partition by is done on the department, and we have applied the ordering on the sale amount descending. So this will split the department sales into 2 tiers. Execute the query and see the result. So this is the output, and we can see that the sale amount of 950 and 900 is treated as rank 1. So this is the higher amount of sale amount done within the clothing department, and the sale amount of 800 and 700, this is assigned as rank 2. So this is comparatively lower amount of sale. So the same is applied for the electronics department as well, we can say. So 1500 and 1200 got the rank 1, and then 1100 and 900 got the rank of 2. So that means this is a poor performance cell. So now let's see lead and lag functions in PostgreSQL database. So lag function will give the previous record from the current record, and lead will give the data for the next record from the current record. So in this case, we are trying to see the previous sale amount from the current record and the next sale amount from the current record. So how we do that? So we write the lag, then the column name and comma 1. So that means we want to see the previous one record. If we apply here 2, so it will show me second previous record. This is optional, we can omit that. If we don't write it, so it will by default take 1 as well. So in the lag function, we have done the partition by employee name and order by sale date. So to see the previous sale, and for the lead function, we'll see the next sale amount. So let's execute the query and see the result. So here we can see the result. So this is the current data, and for this current record, if we see, the previous cell was null because there was no previous cell, because this is the first cell and the next cell is of 1100. So in the record we can see that this is the next cell amount, and yes, it is 1100. So for example, for other employee Devanshi, we can say, so the previous cell amount was null, there was no previous cell, but the next cell is of 900. So that we can see in the, so this is how lead and lag function work in PostgreSQL. So the conclusion is, window functions are a powerful tool in PostgreSQL for writing analytical queries, and they allow you to perform calculations across rows without collapsing them into groups, as we saw in the examples. From simple totals to ranking, moving averages, lead lag analysis, and many more functions are there that we can use within the window functions. So this was all about window function processing in PostgreSQL database. If the video was helpful, do like the video and subscribe the channel to get the notifications for upcoming videos. In the next video, we'll discuss the topic of select list in PostgreSQL queries. So let's meet in the next video. Till then, take care. Bye bye.